again paste this collaborative HackMD documents link on the chat, one of my NRIS colleagues. So this is the document we will use to interact during the course. You can ask questions here, and it contains general information of the course, and below of these documents which I'm sharing, you can ask questions. How to do that? On the left side of the, on top left, you see the pen icon. You can press it and you can edit it. So here we have asked some icebreaker questions. While I mentioned the logistics of the course, you can answer these questions, like 3 questions we have asked here. Each of you can edit it together. It's based on the markdown syntax. So you just go here and edit. Answer these 3 questions, and below of this document, you can ask questions, and our NRIS staff will answer this question, and some of the question we'll take during the discussion as well. Okay, please answer the icebreaker questions, and meanwhile, I will go through the general information regarding the course. So you see that on first, you see the link to this document. This contains all the information like schedule and course materials for these 3 days. And many of you might be wondering, who are we? And we are NRIS staff. NRIS is a short form of Norwegian Research Infrastructure Services. So it's a collaboration of 5 organizations, 4 universities, University of Tromsø, University of NTNU, and University of Oslo, and University of Bergen, together with the Sigma 2 staff who operates the national HPC systems and storage system, and we provide all the services. You could find more about us in the on the NRIS webpage. And one more thing I would like to mention is that we will have a follow-up course after this on 1st to 3rd November. So you all are welcome to register for this course. This will be a follow-up, and we will include more topics which you would like to, which is more useful for you to when you learn more on HPC. After this is a follow-up course, and as I mentioned, you can find the schedule here and the course material. And one important thing is we follow Carpentry Code of Conduct. That means being respectful to each other. That's exactly mean that. And if you think, if you observe some violation of the code of conduct, you are welcome to contact us. You can send me an email, or during the event, you can send me a private message on chat. But I would like to have an email report, but I hope we all will be being respectful to each other. And during the registration process, we have asked your wish list, which topic you would like to get trained. So many of you have listed some topics, and we are listing it in the collaborative document. This course is mostly on HPC intro and Unix for HPC. Most of this wish list are not included on this in this particular course, but most of the things are in the documentation, and the next follow-up course and during first week of November, we will discuss many of these topics. And some of the topics we will take it to the next semester, and say a Q&A session we organize at NRIS, and we will advertise this using the Sigma 2 newsletter. So you can see the answer what we have it today, but more will be on follow-up course. Okay, I see that a couple of you have answered the icebreaker questions, and please answer this and ask questions.
Can I just say one thing?
Yes.
Yeah. At this point, if anyone has problems finding the HackMD document or finding anything, please let us know.
Yeah. Thank you, Maiken. Just want to mention this was included in my email communication as well as it's pasted on this Zoom chat. And if you are lost, you should be connected using the Zoom link, which I sent via email. This HackMD document is public, and so we are not including the Zoom link here. And one more thing regarding editing, this collaborative document that we will be publishing this later today, each day's question and answer. So please don't use sensitive information like names and things when you ask questions. Yeah, I think I have mentioned most of the things I would like to. And today you will have 3 instructors, and I will give this Zoom dice to them. And before that, I would like to say, enjoy the course and thank you again for joining us. And yes, Sabry, Maiken, and Bjørn, could you introduce yourself and take over the Zoom dice? Thank you.
Yes, thank you, Dania. Before I forget, in the HackMD, if everybody could click on the pencil icon once at least, and then go to the view mode. There might be some bugs that it might not update it. So at least click once the pencil icon and then go back to your view mode. And when you're not typing, it's better to be on the view mode to reduce the load. Yeah, I'm Sabry from University of Oslo. I've been involved in this HPC training for a while now, and looking forward for a collaborative learning. That means like I'm also hoping to learn some things from this course. Maiken?
Yes, hello. I'm Maiken, also at the University of Oslo, work with Sabry there. I'm the first time I'm actually teaching in this NRIS course, but I've joined as helper in previous ones.
Bjørn?
Yeah, my name is Bjørn Lindi. I'm working at NTNU, at the HPC group at NTNU. This is the first time I'm teaching at this NRIS course, so I'm looking forward to doing that.
Yes, so the first lesson, we will, me and Maiken will take it, and other colleagues, they will introduce themselves when they come online. All right, so exciting. One disclaimer before we start proceedings. This is a very basic introduction to Unix on HPC. So we are not going to teach a lot of Unix. What we are going to discuss rather than teaching and learn together is that enough Unix in order to understand the HPC lesson which comes after next. So if you have been on the terminal for a while and you know your way around the terminal, this might be a little boring. But if you are here, I recommend that you follow and maybe help others answer when they have issues. So when you try to teach somebody something, when you try to tell somebody how to do something, it's get a better understanding for yourself of that concept. So Maiken, shall we get started?
Yes, let's do that.
Yes. So Maiken, there is a prerequisite for this course. So I said we are trying to do it in a very basic level. The prerequisite is that you should have an HPC account. The reason for that is we are going to use our computer to log into this HPC system and do everything there, not on our laptop. So all the Unix practices, all the Unix commands that we are going to practice is going to be in the HPC system itself. There are several reasons for that. first reason is we are learning these things, tricks, and other. We are going to get this. Get us familiarized with these commands in order to use these HPC systems. As I said, we are not going to learn a lot of Unix. The other thing is to be uniform. Like the instructors would be there as well, and you'll be there as well. So when you type things, when you ask which current directory you are in, it will show familiar or like comparable outputs. So first thing, there's expectation that everybody has an account. For the completion of the sort of the teaching material, we have included here. If you're following it later on, or somebody who's not here, that they wanted to get an account. By the way, Maiken, is my font large enough to read?
Let me just, for me, it's okay.
Okay. So I will use this chance to tell a little bit about this tabs as well. So we try to sort of consolidate all the teaching material into one place. So our main clusters, the national clusters, are Saga, Fram, and Betsy. But we also have local clusters like Fox at University of Oslo, and there are other things coming up. So we have grouped this together. So if you see that there are tabs that you can go around. So this gives mainly two benefits. Maybe there are the benefits as well. One is to give a chance for all our university, our colleagues to contribute to one place so we can improve one material. Another thing is transferring from one place to another. So if you have been using Fox and if you want to do something bigger, you can go to Saga. The similar things, how you do it. So it's comparable. So I'm just showing you later on, but we'll be focusing on the Saga tab today. So the first one is Saga, Fram, and Betsy are the same, but later on we'll be focusing on the Saga tab. So Dania, while we go on, please keep a track on the time. Like if I spend too much time on certain things, give me an indication, please.
Yeah. Okay.
Yeah. So then some notes for ourselves. So as I mentioned, we are not going to learn a lot of Unix, but just enough know-how so we can navigate ourselves inside the HPC system and to understand the lessons later on. Let's sort of motivate ourselves a little bit. So in the HackMD, we have this question here. What are the methods that you use in order to interact with the computer? So how you tell the computer to perform certain tasks? So these days, even the voice works, right? So I could ask my, what is a Unix shell?
According to Wikipedia, a Unix shell is a command line interpreter or shell that provides a command line user interface for Unix-like operating systems.
Yeah, so you could just ask. Or you could use your terminal to sort of type things to the computer that we will learn a little bit later. And you could use your mouse, to go somewhere like to point to something and click. And there are several other ways, like even old times, they might be used like a punch card system or something. So there are so many ways to tell the computer what to do. So I see that there are people are typing here, but I only see 4 answers. So I just want to make sure that people know how to use the HackMD. If you don't, please let us know. And when you, so there are several views. You can have this split view or the view. So there are 3 icons here. In order to type something, you need to click the pencil icon. So I'm expecting that we'll have more interaction during the lesson using this HackMD. And this command line interface is one of these methods to tell the computer in a nice way and an organized and a structured way that, do this for me, do this task. Find me the file which is called myname.txt, that sort of thing. So those things you could also do with the like a graphical user interface as well. Maiken, how would you find a file on your Mac? On your Mac, how do you want to find something? How do you do that?
Yeah, sometimes I just use the Finder, but other times I use the shell and use the Linux commands.
Yes. So when it comes to certain tasks, let's say I have this folder with many files. I think there are hundreds of files. If I want to rename one of these files, I could click on it and I could say new and rename it. But doing the same thing for hundreds of files is not that convenient using the mouse. But in a command line interface that you're going to learn using terminals, using a certain language called bash, we could do this in a more easier way. So the repetitive tasks. And also, let's say the renaming I did, you had to do for 100 renames. And one of our other colleagues has the same, maybe our supervisor or a student has the same set of files. They also want to do the same thing, like the reproducibility. So you could create a small script and send it around. So the same thing would happen in another place. So that's kind of motivation that we are sort of spending our time to learn these things. I'm not going to go deep into what Unix is and the background of it. So it's the one of the oldest and the most robust operating systems ever made. There are multiple flavors of it. We're not going to learn all of it, but just an introduction. If you're using Mac OS or Ubuntu or a Chrome OS or other versions of Unix, Red Hat, you are on Unix, unless Windows is sort of the exception in this case. Here we have some, let me try to, yes. So here we have some terms coming up. Different people refer to this command line interface that we are talking about in different ways. So they would say, or like we would say, terminal, command line, Unix shell, Unix terminal, multiple. That might be a little confusing at certain points. But for these lessons, you could think all of them refer to the same thing. So we will be using a program called shell in order to execute commands in a language called bash. So the terminal, bash, and shell are sort of interchangeable, but it is enough to understand that we are using a program like any other program. It's called a shell, and we're going to use a syntax, bash syntax, in order to execute things. Is that okay, Maiken? Do you have more clarifications?
I think it's okay. I mean, if you're completely new to this, it might still be confusing, but you'll get into it when you'll get used to it, basically.
Yes. So the best way is to try it. All right. So first we had to find this terminal, Maiken. So what is this terminal that we've been talking about all this time? We have some screenshots here, how to find the terminal. Before we start this terminal, if one of our colleagues could start this poll, voting, I found my terminal and I cannot find my terminal, the two options, and give the people two chance to indicate whether they found it or not. That would be easier. So I don't have to go deep into finding terminals on all operating systems. So if everybody has already found the terminal, then we could go to the next part. So start that poll on the HackMD somewhere, yeah. Where I go to place it. When that is done, give me an indication. So my terminal is on. I'm on an operating system called Ubuntu. So it's look like this. So it's a place. It's a box with something we call a prompt that I can execute commands. But in newer versions of Windows even, they also have a terminal. Let me find. So this is a Windows machine that I see. So here you could also have the Windows Unix components installed. Even if that is not installed, even if you type terminal, even the Windows command prompt has enough. So it also has the power to connect to our cluster. So it's not a terminal, but it is something like a terminal. But this command, the command prompt could also be used to connect to our cluster. So I'll show that in a moment. So I'm just taking some time so people can find their terminal. Where did we paste the question?
It's below.
Below, yeah.
Bottom of the page.
Yes, yeah. So please go on. I'm just talking until we have some idea of, because if we can't find the terminal, we can't go beyond this point. So we must have it. So the best thing is to find your the search box where you find programs and type terminal is the most sort of cross-platform thing. In some machines, it might, in some operating system, it might also work if you press the Alt key, Control key, and the letter T at the same time, the terminal might pop up. Let's see. Okay, so if you have found it, have a 0 here. You don't have to type that you have found it. If you have not found it, 0 or O, letter O.
So we're 43 participants, I see, including, of course, the NRIS staff.
Yes.
So we should have quite many answers.
So in another 2 minutes, if I don't get a no, I will move forward.
Yes, probably the best is if you have problems, add a no in the, so we know whether you have problems.
Little pause so people to find the terminal. Let's see. Yeah, so Maiken, it seems good. There are no no's yet. Hopefully there will be none.
Shout out here. You can also use the reactions in Zoom if you want to raise a question.
Yes. So I think Maiken, in general, people know not that they know how to use it, but they have found the terminal. So in a terminal, you have these parts. So we have this example command here, echo. You could type this and see as well. Once you found the terminal, just to have a feel of it. So we call this the prompt. And this prompt, so as you see that I didn't type that, it's already there. So you should never type this part, only this part that you type. And this prompt will be different for you. It should be the same. So if it is the same, tell me, because that means that you are hacked into my account. That's not good. So it should be different for you. After this dollar, you have this command. We tell the computer echo, like print it for me, or like say it for me. And then we have this argument, which is $0, which is special argument, which is a variable, we call it, because it starts with the $. That means there's a value for it. So it prints. So this is the language that we are going to use. So I have some other terminals opened as well. For example, this one is SH. So that's also okay for in order to connect. You don't have to have bash in your terminal in order to connect to our clusters, because after you connect to our clusters, you could start using bash. One more last look to see whether there are any no's. Super. Yeah. Then, so this is the current cell, and again, the message is don't type the prompt. Like in later on exercises, we'll be typing. This means that after what you have to type what's after the font, and this line after the prompt is the cursor. That is where the next input will happen, like when you press the next keyboard. So then we talk a little bit about a program called SSH. So this SSH program is, if you maybe it's easier for me to use this diagram in order to explain this. So you are here on your laptop. So you're here on a laptop. Usually what you do is when you want to start a program, you click on it or you use your terminal to start it, and until when it is the program has finished the execution, you'll see the results. But now, Maiken, what you're going to do is we're going to use our keyboard to type some things on somewhere else. So specifically on the Saga cluster. So I'm sitting like somewhere near Oslo, and I'm going to use my keyboard to send messages to Trondheim, to Saga, through the internet. So it goes through the internet, all the commands. And then the output, I'm telling the computer to do something, and the result of it, it's going to come back to me, to my laptop. So this might be a slight paradigm shift if you are sort of very new to this, because we are used to work with something just in front of us, not something remote. In addition, we are going to use the terminal in order to do this. So we don't invoke a graphical user interface on the remote system. We use the terminal in order to do this communication. So in order to this communication happens, we need some standard rules. These computers should have like a standard address, like a home address, that when you could reach them, and something called protocols. Protocols means that a standard set of rules. This is how you should do these things. So for that, we use a protocol called SSH, and we also have a program with the same name, SSH. So we're going to use that program in order to send instructions to the cluster and to get back results. So for this, we need a program called SSH. On your terminal that you typed, that you found moments ago. So I want you to type with me here as well. Find out whether you have SSH with a minus or a dash and a capital V to see whether you get a result. Please open another poll, my dear colleagues. I have SSH. I do not have SSH. And also include the options. I'm not lost. You don't know what SSH is. You're still confused. That's fine. Like if you're confused, you have to tell us so we can address that. So even on Windows systems, if you have SSH -v, you have something called this Libre SSH. That's also fine for the rest of our course. And then there might be older versions as well. Let's say SSH. If you get a command, like if you're in the terminal, and if it says SSH not found, that's bad. So you have to tell us now if that happens. So when you press that, it should be SSH -v. So I have like all sort of terminals set up. If you face this issue, we'll see whether we can solve it now, because this is the main part that we need apart from locating the terminal to go forward. So SSH-V is what you need, and it's a capital V. So if you have a simple V by mistake, it will print certain things that would not mean so. So Maiken, I forgot to mention that it's very important in Unix. It's case sensitive. So if it's simple, it's capital, it's capital.
Yeah, if you use the Windows or Mac machines are often also set up case insensitive, you will have to quickly get used to the capital and a lower letter is different in Unix.
Yes. Okay, it's a version. So the V prints the version. We could move that question later on. Yeah.
And of course, you'll all have a different version.
Yes. So yeah, definitely. So I also have some terminal with multiple versions. Here, this is bad. No SSH, right? This is okay. It's a different batch. This is a different flavor of the shell, but it's fine. This is fine as well. Oh, sorry, that's the wrong terminal.
I think we can move forward.
Yes. So we have our SSH, we have our terminal, and I think we are all set. This it's a good. I see a good vibe, Maiken. So next thing is to log into our cluster SSH. So as I mentioned, we are on our laptop. We are going to travel through the internet and establish a connection with Saga, so we can type things directly on Saga. Excited. Okay, let's see. Here, when I'll reiterate certain things, Maiken, a little bit. The prompt, we don't type. And SSH is the command. And this is the argument. And here I say that my username. So Maiken, here this is to be sort of a general way to say that here you should replace your username with this text. So that's also mentioned here. So if I type SSH my username at saga.sigma2.no. So this is the location of the cluster. This will not work because there are no my users on the cluster. Here, what I should do is I should use my username, and don't use my username either. You have to use your username that you got from when you created the account. And Saga, the cluster, we're going to sigma2.no. Type that. So type with me and press the enter key and see what happens. When you press this, if you are doing it for the very first time, you might get a warning which says, yes, okay. SSH, that protocol and the command, it analyzed what you try to do, and it found out that there's a cluster, there's a place called saga.sigma2.no on the internet, found it, and it found that this is the first time you're going to connect to it, and it has this fingerprint, which is a unique identity for that cluster or the place that you're going to connect, which makes you avoid any accidental connection to some malicious site. Let's say instead of sigma2.ni, you type ni, but somebody created something called saga sigma2.ni. And when you try to connect to it, it finds a fingerprint. And this fingerprint, we have given it in our documentation. Please place that link, our colleagues on the HackMD, where you could compare. For this, I'm sure. So this is the one. But if you let it be here for a long time, it might not work either. So I might have to type again. Let's see. Okay. Let's see. Then my username. So when I'm typing the password, you don't see anything. So that is how it is made. After you press enter, then you will see the things. But if you leave this SSH open for a long time, you might not see that either. I mean, you might get a disconnection if you have this message long time. So you have to press enter immediately after the command that comes. So then you'll ask for the password. It'll ask for the password, and you enter it, and you are in Saga. Saga.sigma2.1. So the next time when you enter, it will not ask for it will not ask whether you want to confirm or not, but you will directly go into Saga. Once you reach that place, try to reach that place. So we can have another poll, which is I managed logged in to Saga.
Okay, yeah. Before that, Sabry, I would like to say, if any of you don't have an account, you didn't apply when we send the email communication, you can still follow the course, and maybe if you can apply today, you can work on tomorrow as well if you don't have an account yet. Yeah.
Yes. So once you are on Saga, I'm giving some more minutes. We have 1 more minute for the next part to begin. Let's see whether we can see some. So once you are on Saga, you can type the command called hostname to verify that you're on Saga. So this might be login 1, login 2. You might land on different login nodes because for the load balancing, when many people log in for this at the same time, there are many front-end nodes that you could you might be landing on. So this does not have to be the same. So if you land on login-5 for example, you might even say saga.sigma2.10 full address. Yes, so the PuTTY, we didn't encourage PuTTY during these lessons because now all the operating systems, they have some way of natively establishing the connection. Or we have another, if you are in a very old version of Windows 7, for example, Danya might have sent you a special software that you need to install. PuTTY is you could also establish the connection, that's fine. But in this lesson, we expect you to find some sort of terminal program in order to connect to Saga. So how does it log into Saga? Yes. Okay, so I don't have user account that you have to follow today and maybe apply. So without that account, you can't do other exercises. So even on Windows, let's try that, whether it's work.
So there was a comment on the Zoom chat, the registration is closed. It is not. I guess the registration for the course is closed, but we can still process new accounts, I guess, for the course. Is that correct, Anya?
Yes.
Yes.
I see that a couple of users applied for account today, and they will get access within 15 minutes. That's what I was told.
Oh, that's nice.
So those who applied, wait for 15 minutes. It will be ready.
Yes.
Thanks.
Yes. So I'm going 2 minutes over the time now. If I don't see any no's, maybe 1 more minute. And one thing that might happen is another thing is without the sigma2.1, if you don't type your username, sometimes it might work if the username on your laptop and the Saga is the same. But in this case, if you see that it will go as not me. So then let's see. No, can't. No, okay. Let's see. Message.
Danya, can I ask one extra question? Is there something special they have to write when they apply for the user account?
That was communicated via
Okay.
email, all the
Good.
data.
Follow the email then.
Yes.
Yes, as you can see, if I don't type the username, it takes the username on your laptop or a computer that you are in and try to log in. If this is not the same as the one you got from the Sigma 2 accounts, that it will not work. So you always have to do search your username. Then land on Saga, then the host. So if you're on your, when you're on Saga and if you want to come out of it, you type the command exit and you can come back to your laptop. Right. So those things are also summarized here. So how to, the way to come out of, log out of Saga is exit. So I'm 4 minutes delayed, but I think it was very important that everybody got on board and there are no no's here. So our next colleague, so Maiken, would you like to take on the screen and continue with this?
Yes. Let's see, you're still, shall I just take it then? Or will you stop sharing first?
Yes, just steal it from me.
Okay.
So that way that we don't stop the, we don't like, there's no something in between.
Okay, how does that look?
It looks good.
Good. Let's see if I can. Do you see this? Is there like a little black thing on the bottom here, or see if I can move that? Collapse, or is it? Yeah. Okay. I think maybe the Zoom. The Zoom.
It's fine for me.
Very good. Okay. Yes. So let's start learning commands we can do in the shell now. And now that we've logged into Saga. So first of all, I want to tell you that there is a cheat sheet that we made. So if you go to if you see the contents tab here or the menu here on the side, there is a Linux command sheet here. So in this one, if you click on it, you have to actually scroll to the side here to see the full document. But here is a list of the commands that we're using today. So if you get a bit lost in what CD stands for, you can have a look here. It says change directory, for example, and then it's a little bit of how to use it. This is very basic, but and there's many more things and options, but at least you have the list of the commands we use here, so you can use that as a reference. So now we're going to go to the moving around and looking at things. So we'll learn how to navigate through the folders, and we'll learn how to create and copy and move and rename and remove some files and folders, and look into the contents of files via the terminal, and we'll also look at how to compare files. So we'll first have a demo part and teaching part, which will be 15 minutes. Then we'll have a little break, and then we'll do the exercise. And then in the demo part, you can type along, but we won't stop for you to kind of follow through the whole demo and typing along. That will be like dedicated time in the exercise where we will help you in breakout rooms on Zoom. But if you want to type along as we go through this, you have to start here with this set of commands, and you can use this copy icon here. If you copy there, all this stuff here will be copied to your clipboard. So now I have already logged into Saga. Here I am in my terminal, and I will paste with Command V for me, because I'm on a Mac, all these commands, and it did everything for me. You don't have to worry about what it's doing at the moment. We'll go through this. And now I have actually...
So Maiken, why did you have to do that? So what is this requirement?
Yes,
for this
so sorry, I forgot to say that. So the reason for you having to do this if you want to type along is because this is a folder structure that we will be using in this tutorial. There's some files there's some folders, and this is the material we'll be using to learn how to navigate and move around in the terminal. So yeah, get hold of this. You can also just copy one command at a time from here to your terminal, or you can use this copy button that does everything, paste everything in one go. Okay, so let's now start finding out and navigating where we are. So I did all this, and when I do PWD, which I'll tell you what is in a second, you see that for me, I have this output, and PWD means print working directory. It's basically tell me, where am I now? Where in the file hierarchy am I? So for you, you will see here it says user on the training material. And for me, my user is Maiken P, and for you, it will be your user, obviously. So as we're all in Saga, this will look the same for you. The only difference will be the user name here is just different. If you pasted these commands on your laptop, not logging in remotely to Saga, it would be a different path here. We call this the path. So yes, now I have found out I am in this folder, in the demo moving around folder. But I would also like to see what is in this folder, and that is ls. I've forgotten what S stands for, but it's a list. Maybe it's just list. If the S stands for something particular, you can tell me, or I'll check the cheat sheet. Let's see, I'll go to the cheat sheet.
So Maiken, when you use this Unix command, sometimes it could be like little cryptic, like, you know, yeah. Because it's historically some people develop their
sometimes the name doesn't make sense. Yes.
Yes, and you just have to learn some basic commands to get started with.
Yes. And this says, well, list is just list contents of directory. So the S is probably there just there because there's an S in list. So that's correct, completely true what Sabry said, that, you know, it says also here in the teaching material that, you know, some of the names are not so obvious. It says if you go further down, yeah, let's not scroll there, but it's the names can be historical and not self-explanatory sometimes. So, but let's try to list what's in the directory. I'll do ls. Okay, and here I see the contents of the directory. I see there's and I have different colors here also. So for me, usually there will be some color coding in your terminal. Depends, you can also set that up in the way that you wish. For me, I have blue that shows that there are folders, and the black ones are just text or files.
Yeah. Maiken,
yeah.
Are the participants expected to type along, or?
Yes, they can type along. And so, as I said in the beginning, if you want to type along, you need to copy and copy these commands from the top here, and you can type along. But in the exercise, you will be trying all these together. So we're not going to stop to help the type along part. I'll be demonstrating the commands, and then in the exercise, you will get more help.
So if you're very new to Unix, I recommend you look what Maiken's doing and practice during your exercise session.
Yeah, because it can be a bit confusing. You get stopped, you're trying to do the command, it doesn't work quite for you. But at the same time I'm speaking, it can be difficult to follow everything. So if you're finding yourself that it's hard to type along as I speak, just try to listen and see what I'm doing. And then in the exercise, you can practice and you will get some more help. Yes. So another thing that's important with Unix commands is that there are always more options that you can add. So for example, the options are typically, or flags, so they typically are specified with a dash or 2 dashes. So if I do ls-l, you see there's more information here. For example, here I see there's a D, that means that it's a directory. And then there's different letters here. And this shows what kind of permissions the file has. R is read, I'll show here on the terminal. R is read, W is write, X is execute. And then there's 3 pairs of this. And that's because it's who can do it. So the user, a group, or everyone. Yeah, you will learn more about that later. But basically this first line shows you if it's a directory and what permissions the file or the folder has. And here is the user that owns the file. And there's also something called a group in Unix. So a user always belongs to some one or several groups. And then when the file was, I think, created or last updated, yes, last updated, and then the name. I'll tell you now already, but it comes further down also, that in Unix, there is a command called man, and that's manual. And you'll really have use of that command, because that's, if you don't know what a command means, just write man ls, and you will get a manual, basically, explaining all the options on how to use the command. To get out of it, press Q. Okay. So let's do ls again. Okay, I'm here. Sometimes people want to have look at the manual pages on the web browser, and that's also possible. So in the web browser, I can write man ls, and I get to the Linux manual pages, or you can write Linux manual or to make sure you get to the right place. And then you can read it in the web browser, which you might find is nicer. Okay, another option here, ls-lh. H is here, human-friendly output. And what's human-friendly about it? Well, it's actually, in this case, it's just that the size is written with, instead of bytes, is written with kilobytes or megabytes or gigabytes, the size of the file. Up here, you see it's, I'll show you in the terminal, sorry, it's 140164 bytes, but down here it says 137 kilobytes instead. It's a bit easier to see what size the file is. Let's see. Okay, so a very important thing with Linux commands is that you can use wildcards. Wildcards is basically something you use. It's a symbol that's used that can be replaced by anything. So if you say ls-l *txt, it will list all the files ending in txt no matter what is in front. So the wildcard is here used to say, no matter what's in the front, what the call can be maiken.txt or whatever .txt, it will list those files. So here I see that in the folder that I see poem.txt and unfinished.txt. And yes, if we inspect from the command before, in this folder, you see that that's correct. There's two files here with .txt. That's poem.txt and unfinished.txt. So the wildcard is very much used and very useful. Yes, so here is the information about the man pages. When you go into the man pages, as I said, when I was in there, you have to use Q for quit. You might get a bit lost here because this opens like an editor that you might not be used to and you don't know how to get out. And to get out, you just use Q for quit.
So Maiken,
yeah,
because we are sort of approaching a break now.
Yeah.
Shall we show this creating directory part? So the rest, as you have clearly mentioned and explained, there are how to use the commands and how to get additional output and all. So we'll go.
Shall we take the break now, or shall we push it 5 minutes since we went over time?
No. We'll. That was yeah. We all lost 5 minutes from my lecture. So we will talk about this making how to create a directory, and then we'll take a break.
Okay, that's fine.
And after the break, we could do the exercise, and during the exercise, we could in breakout rooms, we could go more in depth.
Yes. So let's then go to the creating, copying, renaming, moving, and removing files. Is that one you mean, Sabry?
Yeah, so that one is sometimes I get confused. Sometimes to how to come back to my home and then how to create a folder.
Okay, so now we've learned how to see where we are and just list what's in the directory, but let's try to move around now. So first of all, I was here in the demo moving around. Sometimes if you move around, you might get lost. And to get home to your kind of home area, you can just do CD, which is change directory, and enter. If it doesn't have any option, you will be placed back in your home folder. The home folder is the place that you will get into automatically when you log in. So that's the starting point when you log in. So let's go back now into the demo moving around so that we know that we are, so that we know we are in the same place. Change directory, and then write the folder that you want to go into. I'll just mention that you can use the tab if you don't want to write the whole name, and it'll find, if you type the first part right, it'll find your the name for you, and you can write enter. Press enter. Okay, so let's now make a new folder. That you can do by using the mkdir command, make directory, mkdir, and then the next option or the argument here is the name that you want to give that folder, and we'll just call it new folder. Okay, let's do ls to see if that folder was made. Yes, here it is, new folder. Yes, and then let's do another command. Let's copy a file to another file. So here, copy poem text to poem2 text. I'll just write that command. So in the copy cp command, it's from file to file. And that means that now we should have a new file here called poem2 text, and we do. So the next thing I want to do is now I want to copy the file into that new folder that we have. So you see in the copy command, you can have both if you want to copy one file to another file, but you can also copy a file into a new folder. So let's see what happens then. Copy poem.txt to new folder. Let's see what we have in the new folder. ls new folder, enter. Yes, I managed to copy that file into the new folder. So it will understand, Bash will, or it will understand that it's a folder that we're trying to do, so it won't overwrite that folder and put make the folder into the poem text file. It will actually put the file into the new folder.
So Maiken, Unix would automatically identify the last argument I give if it's a file or a folder. So if it is a file name, then it will rename, create a copy. And if it is a folder, it will move copy the content to that file.
Exactly.
The folder.
So if you're trying to copy, yes, exactly. So the second argument there, it will check if it's a file or a folder, and if it's a folder, it will copy into the folder and not overwrite it. And you can also copy several files at once. So let's try that. The important thing there is that the last argument is the destination, the folder. So if you try this with 3 files, it will not work in the same way. So copy poem text, poem2. Actually, we've already copied poem text. So anyway, into some folder. Let's just, sorry, I'll just broke that command because I want to have a look in some folder first. ls some folder. There's just the example file there. So, okay, that's fine. Poem.txt, poem2.txt, some folder there. Let's look in the some folder. Yes, I have both the files in there. Another command, instead of copying, you can move. That's mv. So let's move poem2 to poem3 file. Poem2. There is no poem3 text file yet, but in this command, it will create a new one actually. Text. Okay, so what's happened? Let me do ls. Yes, now I see I don't have any more a poem2 text file, but I have a poem.txt file and a poem3.txt file. And the poem3.txt file is the one I just created with this command. And last command, to remove a file, rm. Let's remove again the poem3 text file to ls. Yes, the poem3 is now gone. And I can also remove a whole directory, but I have to give it an option here, or flag -r, which means recursive. So let's try that. rm-r, and I just want to remove my whole new folder with all the contents. Let's see if that worked. Yes, there's no new folder anymore. Okay, so that was a quick throughput of some of the commands.
Yes, thank you, Maiken. So when you copy, your original copy remains, but when you move, the original is disappearing, right?
Yes. So copy does as it expects. It copies a file or a folder, and move actually moves it, so the original will be gone.
Yes.
And
so
rm is to remove a file completely or a folder.
So just a tip on the cluster, the file system we have on Saga and Trum and other things, moving could be immediate, like it's very fast, but copying would take time. It's because it's you will notice that when you're doing it on the cluster itself. Now I think, Maiken, what we do is we go for the original 10 minutes break. We don't reduce the break. Later on a session coming up that we could manage.
Yeah.
We go for the 10 minutes break.
Before
yeah,
that,
go ahead,
Sabry, I have a question to both of you instructors. So when you do RM, it's permanently got deleted, not like on Windows or Mac. It will not go to trash and then you have
yes,
to empty
so it's
it.
very
That's important.
So
yeah.
If you're on the terminal and you write RM, remove something, it will be gone. Okay. I've many times removed files, which was by mistake, and you can get into the habit of using the flag I, which is interactive. If I do that, it will actually, sorry, I did a stupid thing. Ask you if you want to remove it or not, so you can be sure. And you can, there's ways of doing this automatically also. So be aware you won't find it in your trash afterwards.
Yeah, thank you, Maiken and Sabry. Shall we go for a break? And after break,
yes.
we can come to the main room and you can mention the exercise. Then participants can go to the exercise room. Is that clear?
Yeah. Yes.
Okay.
Yes.
Okay, then we will be back 20 minutes past 10.
Yeah, great.
Yeah. Back. Before that, I want to tell Sabry or Maiken, one of you should go to one of the breakout room I have assigned on Slack. You can find it. But yeah, welcome back. Now Maiken will explain the exercise and we will have a 15 minutes exercise on breakout rooms. If you want to do exercise by your own, you can still stay on main room. But in exercise rooms, you will have NRIS expert helpers who will help you during the exercise time. Okay. Yeah, please, Maiken.
Yes. So, okay. So we have not, first of all, we have not gone through all the commands. So if I scroll up again here, there are more commands here for printing and comparing file contents. So what I suggest is that when you start the exercises now, you just go, you know, from one to and down to the different exercises and do what you can. If you're fast, you can just continue on the tutorial and, you know, read the instructions and try that. So I propose you just do what you can. If you want, yeah, it's good to go into the breakout room, as Tanya said, to get proper help, or you can stay in the main room.
Yeah, I will open the breakout room now. And before closing, I will send a message. If you need some more time, please indicate on HackMD. Just opening the all rooms.
Before you go there, to me, it was not clear what we are supposed to do. Is it the green box or is it everything else than the green box?
Yeah, I forgot to share the screen. So that's the reason. Yeah. Sorry for that. I realized just when Dania started. So yes, the exercises are here in the green box. And those are the exercises that you can do. So we have 15 minutes or something like that for that. And there's also solutions at the bottom here. It's a drop down. You click on it and it expands. So just start from the top and work yourself down and stay either in the main room on Mattermost, Zoom, or in the breakout rooms.
And ask questions on HackMD as well.
Yes.
Doing it. Yeah.
So then just get going and I'll stop talking.
So everyone should be back from breakout room now. So Maiken and Sabry, we would like to summarize and move on to the next session.
Yes, so I don't have much feel of how it went with the exercises. So it would be good if you could in the room that you were on the, let me see if, yeah, on the HackMD in the exercise section there, if you could put a 0 if you think it went okay, or an X if you were struggling in the list of rooms. And obviously, just use this material after the course is done today. And I mean, it's very self-explanatory and easy to navigate through. So yeah, you can come back to it. Sabry, you want to say something?
No, Maiken, we can move to the next lesson.
Okay.
Yeah, thank you. Sabry and Bjørn, we will take over the sessions to create and modify files. Are you ready?
I think it's finding things first.
Oh yeah, finding things. You, Bjørn and Maiken, right? I'm sorry. Yeah. We will have an exercise for finding and things. So I will assign rooms for them, participants. I see that you cannot see the breakout rooms. I'm sorry for that. Yeah, please go ahead, Maiken and Bjørn.
You're muted, Bjørn.
There, now you can hear me.
Yes.
Yes.
So we'll discuss how to find things, how you can download and extract files from the internet, and how we can find files in folders, and also how we can find content in files. So the two commands that we will be using are grep and find. So find can be used to find files, and grep is used to search within files. So you can do this as a type along. We download files with wget, and we will unpack them. So copy this long address.
So Bjørn is just preparing his folder so that he doesn't have everything on top of each other here. You can do the same or
Yes.
not.
So I'll download a finding tar.gzip. And then I'll use a command which is called tape archive, tar, to unpack the package.
And that command you also find in that box that
Yes.
he copied from.
There's more options there. I use only X and F. X is for extracting, F for the file, finding tar.gset. Set V, which is in the documentation, is for listing the files that are extracted. So we'll use the command find. Or we'll have a file called the test data in the working directory. And we will try to find a couple of different files in mess. Let's start a file called output text, which has to be in one of the subfolders. So we'll try to find output text. So the way find works is to find a starting point. That can be the current directory or another directory, and then options to find. find has very many options, so it can be useful to read about find in the manual, like man find, and so there you get more details about find. So now we'll search for find, search for output text, find test data, minus name output text. And there we find one file called output text in one of the subfolders. We could
so the arguments, yes, the first argument is where to find, so where to look.
Yes.
Yeah.
I could also use dot minus name output txt. Then I'm searching the current directory as well as and down into the test data. So you see, yeah. So if we are not sure about the capitalization of our file, whether it was written with small letters or capital letters or a mix, you can use the E name, which is for ignore. Ignore letters. Data minus E name output txt. There I wrote file wrong. So there we find one more file that has which is written with capital letters, output and .txt. So let's imagine that we have forgot the name of a data file we want to use, but we remember it's a CSV file, a comma separated file. How can we then go ahead and search with for CSV files? We will then need to use wildcards. That is signs that can take several values. So the two of the most useful wildcards are the asterisk and the question mark. The asterisk matches 0 or more characters, while the question marks represent any single character. So if we want to list all CSV files, we can use the asterisk like this. Find test data minus I name. And then we get a list of CSV files in this directory.
And here you used quotes around the...
Yes, I need to use quotes. So so not the shell try to understand star CSV, asterisk CSV. So it's sent to the find command for expansion.
Sometimes it works without the quotes also, but it's safer when you use wildcards to add quotes.
Yeah, I think when you use wildcards, you have to use quotes.
Well, for me, it works without also in this case. I don't know exactly why, but yeah.
Okay. So, and we used here also the INAME to match larger CSV files, or CSV files written with capital letters. So the quotation marks make sure that the CSV is interpreted by find more and not the shell. So that's what we discussed. So find can also be used for looking after properties like file size or access and modification date. This can be useful to display only files which have been changed or created in the last minutes or hours. So here we'll create a new file .text with the command touch, create an empty file, and give it the timestamp now, for now. So let's see the attributes for file text. So we see it's created October 18, at 10:55. This file is not much newer than the other files in the folder, and we can find it with either with -min or -mmin option, depending whether we are looking for access or modification time respectively. So let's see what's created in the last 10 minutes. Find test data modification time is less than 10 minutes. Then we see that the test data directory is modified because I got the new file text, which is also listed. So if we had used the modification -min, then +10, then we would have gotten all files that were modified more than 10 minutes ago. So that will be the whole test data subdirectory. So let's look at another property that we want to see all files in our test data, which are larger than 100 kilobytes. We can use the command find test data -size plus 100K. So that's quite a few CSV files that get listed. So, and there, if we wanted to list the files that were less than 100K, we would use the -100K. We can do like this, and then you will get another set of files. So we can then combine the different options to unlock finds fully potential. If we want to find all CSV files which have a size greater than 200 kilobytes, we can use find test data -name CSV size plus 200K. That was one file. So what about you, Maiken? Will you talk about grep?
I hadn't planned.
Okay, I'll continue then.
Okay, thank you.
So now we have used searched in the directory with find, and now we're gonna use grep, where we search for content in the file. So we got a list of genes from a colleague, and we want to analyze for a project. So first, let's find the list with find and have a look at its layout with head. So here, find test data, minus name, gene, list, TSV. So it's there. Head lists with minus N5 the first 5 lines of the file. So we want to search for the word rat in the gene list. Grep rat test gene list TSV. So there is this Rattus norvegicus. But there are supposed to be two. There should be 2 rat genes, so we try with minus I to ignore capitalization. The Rattus norvegicus with capital R. So this time we got both the genes results. We can use grep recursively. So here we show an example where we search for a gene name recursively in the subdirectories. Grep minus R. So it searches for all the files that are in the directory and down, and in the subdirectories. So it's minus N shows the line number, and minus C1 provides us with some context by displaying one line before and after the line containing the search term, containing the HSD17BT. Okay, so now we are having an exercise. So now it's your turn to use find and grep. So the exercise will take 15 minutes.
Yeah, and remember the man pages, the documentation, the Unix documentation pages, man. So use that
Yes.
if you're trying to understand the options and the arguments.
Man grep or man find.
Yeah. And if you prefer to look at the documentation on the web browser, you can write the same in your search in the web browser. Just write Linux in the end, and you'll usually end up on the documentational web.
Yes.
Okay, thank you. I will open this.
Thank you, Dania. So we are in the creating and modifying files lesson. That is the next one. I hope you managed to find files and know how to do these things. If you have more questions, or if you have any specific questions, please use the HackMD to discuss these things. When you work on the remote HPC systems, we usually don't invoke a graphical user interface on the other side, which means we don't get things like Microsoft Word or LibreOffice or things like that. We don't usually use for text editing. And we have to also make sure that in next few, like tomorrow and the next few days, the scripts that we write, the text we see and what the computer sees are the same. What I mean is that when you type in certain text editors, and if you, let's say, if you make a bold text or have a new line, there might be metadata associated with that, which means the computer sees not the text, but something different. So to overcome these things, there are different ways to create pure text files. In this material, we have discussed several of those. So not to rush things, and because we have to cover other things, what I will do is I'll show you two ways to create the files. And the first one, don't follow me, just look at it, because that's sort of like a motivation for the next step. And the second step, we'll follow together. So the first step is just watch me. So I am on Saga. Oops. Here. I'm creating a file, not following the instructions one by one, but I'm maybe this folder is called something different, but but you know how to create a file now. So I'm inside this folder. So one way to create file is to use certain commands that we use for other purposes and redirect the output. For example, we have the command called echo, which will say, if you ask it to echo something, print something, it will print on the terminal itself. But if you use this angle bracket, file with echo m.txt, if you use an angle bracket, then it will not print to the terminal. Instead, it will create a file, and that file inside would contain the line, that first line. So this is a simple way to do that. But if you do a second line, oops, this is what we have. If you have a second line like this, it will overwrite what's in it already, and it will have the second line. So what you do is,
but now you overwrote the file with echo text the way you did it.
Yes. So in order to avoid that, I could create the file again with the first line and leave the file. And as Bjørn pointed out, when you have the second line, you have two arrows to append. So So I use several things here. One is use the command cat that we learned before to check the file content, and also introduce this redirection to files. And also I use my arrow keys on the keyboard to go up and down to get the commands I typed before, so I don't have to type everything. Did I enter? So now the second line is there. So if we could create files like this, but for bash scripts that we need for the HPC job submission, this sort of rudimentary way of creation would not be enough. So I will skip through the rest of the motivation, and I will tell you about a terminal text editor. So a terminal text editor is when you do not establish a graphical user interface connection to the cluster, and it's plain text without artifacts. You don't do any fancy stuff with this text, and that's only. You could, if you already know a text editor like Vim or V or Emacs, you could go through with that. So you don't have to learn this. But if you don't have a favorite text editor, or you don't know what a text editor is, we will learn Nano. So on the next few minutes, I will show you how this Nano works. So Nano is a text editor. The way you invoke Nano, type N-A-N-O, Nano, and a file name as an argument, .txt. So when you press enter, when you press Nano and the file name and enter, what will happen is it will open up like a basic text editor with a blank empty file, or it will open, if the file already exists, it will open that file. So now I want you to try with me, because we are not going to pause for an exercise. Open Nano with me, and we'll see what are the basic instructions are. So the way to open Nano is type the word Nano. Good if it's an empty folder, or if it is one of the earlier folders, it doesn't matter. I created a new folder, so the output I could clearly show you what was created. So Nano, some name, you could give a name, and press enter. So when you press enter, you end up in this interface. So this interface, on the bottom you have certain details. This is the navigation. So if you go and click with the mouse, this will not work. So you have to use your keyboard in order to do things. You need to use the keystrokes, do this. So the first line, I'll just unhide my terminal a little bit more. So when you open it, you will see that the cursor is blinking. So this is where the typing will happen. First line. And then when you want to go to the second line, you use the enter key and the second line. But if you try to use the arrow key further, it will not go beyond the place you have plus press enter. So if you want to go down, you have to press enter, go up, arrow key, right arrow, left arrow. So that is the basic text edition. To edit the document, and then you have to save it. So how to save the document is you have to use this write out option here. This symbol means hold down the control key and press O. So I will try to do that. So what you should do is hold down the control key and press the letter O, and it will prompt you to a file name, which is the file name I used before when I opened Nano. And here you should not change the file name unless you really want to. Then press enter. So let's see what I did. I press the control key, O, together. While holding the control key, I press the O. So that's how I got that menu. Yeah. So try to save that file. And then, I guess you're following with me. Then to get out of Nano, the same way that you did with Control O, you do with a Control X, and you're out. Then if you open the file again, it will not give you a blank page as before, but it will give something with the line. So when you get this one, if you don't want to edit anything, you can again do Control X. So for the next few lessons, when you go on learning Nano, you could have like multiple options here, how to replace text, how to cut, how to paste things. You could learn those things. But for the next few lessons, what you need is how to open it, how to type, how to navigate, how to move around, how to save with Control O, and how to get out with Control X. If you have any more confusions about that, please use the HackMD to discuss. And we will practice that when you have the script lesson. I think you can use this editor if you do not have a favorite editor already. But if you already have one, please go on and using it. Let's just say the HackMD a little bit. Yeah, so I don't, let's see. Is that Nano related? Okay, so on Mac, it's the, what do you call that? Mac and O? What is that key called? Is anybody having a Mac done it? So Maiken, what is
probably
that key called?
Command usually
Command,
instead.
Yes, Command.
This Apple
O.
key.
Yes, Apple key and O.
But I often, in Emacs at least, I use Control. I have a Control button also, but it's, yeah. If Control doesn't work, you use the Command. It's usually the other one.
Yes, as mentioned before, if you already have something, your favorite, go on with it. So Dania, move on to the next lesson now. So we can take on this, because I'm not going to spend too much time on other options, because now we know how to open, write, save, and exit.
Yeah, thank you so much, Sabry. And you can ask question on HackMD, continue asking questions, and Maiken and Bjørn will continue with the scripting session. Are you ready, Bjørn and Maiken? You can share the screen.
Yeah, Bjørn will take the lead.
Okay.
Yes. Scripting. So now we'll create our own commands and save them in a file. Scripts, so the key point is scripts make computer work more automated and reproducible. So scripts can be used as regular programs, so we don't have to remember all the commands all the time, and we can remember the script name. So we'll demonstrate a couple of commands, and later they will be used in an exercise. So we'll do a type along here. So you have the same test data, our test data catalog that we downloaded in the previous lesson. This time we cd into the test data catalog. Creating a bash script. We now have a quite nice set of tools and commands. We are also able to build new ones by stringing together simple commands to form more complex ones.
Actually, that we don't know yet.
No, we haven't. That's what we're supposed to do. So we'll write them down in so we don't forget them, and we can save and share this file or note with others. So here we'll have a file called list.sh, and let's see what it contains. Cat list sh. So it contains the command echo all the PDF files in current folder, and pvd and ls asterisk PDF. So the lines starting with what's that character called again? Maiken, do you know? The comments.
Hash.
The hash, that's right, yeah. The hash are comments, and so they will not be executed as part of the batch script. So let's try it out. Bash list sh. So then it echoes all the PDF files in the current folder, and the current folder shows the prints the working directory, which I have a long string, and then they list the PDF files that are in the current directory.
Can I add something?
Yes, of course.
Yeah. So the first line there, this hash and exclamation mark and bin bash, it basically tells what command to use to execute the file. So there could be Python here, for example.
That's right.
So this is kind of telling if you don't tell in any other way how this file should be executed, it will read this first line and use that.
Yeah. So this bash script is executed with bash script.sh. This we can change somewhat, that we only call list.h. So we don't have to use the bash. So then it behaves more like a real program. Because if the way we want to run it is like this, then the command is not found. And if you try to with the /, then it says permission denied. And the reason for this is that it's doesn't have the execute bit set. So if we list it, we see that the list is only read-writable. So well, what is listed here is permissions on the very left side. So it says it's read-writable and then hyphen, and it's read-writable for the owner, which is my username. It is only readable for groups and readable for the world or others. So so we need the execute bit set for the list.sh to be called as a command.
So the difference here is that when Bjørn wrote bash before, he said use the bash command to execute the file. But when you're just trying to do list.sh or .list.sh, we're not telling which command to use, and that's
so
why it has to be executable.
No, I change the command, modify the bits. So here we see it's writable for me and readable for the group and for the other users. Then I add the execute bit. And now it's executable for me and for the group and for the other users. So now I can run it with as a command. So now we see that it equals all the PDF files in the current folder. So our script worked. So now we have an exercise for you to create a new script and run it. It's a 10 minutes exercise.
Okay. So you have this exercise here. I will open the breakout rooms and we will be back at 5 minutes past 12. Is that okay?
That's okay.
Yeah. And please indicate on HackMD that how it's going.
Yes, well, the next session, we were actually not really, I actually thought we would be short of time, and we were planning not to really go through that properly. What do you say, Sabry? Shall we?
So we'll say something about pipes, because those are important Unix.
And I have to mention, someone already mentioned in the icebreaker question, they want to learn how to compose commands on Unix. So it will be nice.
We have some time anyway.
Yes.
Yeah. So is there anything else before we Radwan, is there anything specific that we want to mention from the HackMD, that something we missed?
No, I think everything is answered, and I will try to raise sort of understanding questions. But please keep the questions coming. It's fun to read and answer.
Okay. So Maiken, what I'll do is then I will take the lead and you can help me.
Yeah, great.
Yeah. So I'm on Saga now on the login node 4.
You are not sharing, Sabry. Are you supposed to share the screen?
Definitely yes.
And you are not.
Okay. Let me wait. What happened? Oh yes.
Yes.
Okay, from the beginning. So you have to. So you have. Excuse me. Made this exercise folder that you could copy and or to your home directory on Saga and to practice with us. So I'm going to issue the command cd. So I'll end up in my home directory again, and I'm going to copy and paste and then follow these commands, and I have this directory called exercises under pipe. pwd to check the current working directory or the print working directory, and ls to see the files. So we have this these files and a folder, 2 files and a folder to work with. Let's try some of the examples with these files. So we have some generic examples. So this how to sort, how to unique. So we'll try those on the real files. So before that, the nano editor that we know of, that we learned before, we'll open the file called repetitive text. So when you open this, I'll get some more real estate in this. You'll find some repetitive lines, right? Of course, you can go and manually check these things inside Nano, but there are other commands that you could use in order to do things like find out whether the word blue is in this file, or how many unique lines are there, because there are some repetitive lines. Count the number of unique lines, and can you to sort these. So I'm going to get out of Nano with Control X or Command X on Mac, and grep for the word blue. In this case, you might not even need the file. So the inside this, so what I'm asking is to find the word blue. So you will find many of those. So the piping is that if I want to use the output of one command as an input to another, so I use the command rep here. So I'm going to place a hash in front, so that will not execute. So you can see the command, or you can also see the command in my history window. So I stop executing it.
I'll just mention the hash here is used for, it's a comment. So it comments out the line. You can use that in your script language, in your scripting also.
Scripting, yes. Then there's another command called wc, word count. This will count how many lines are there in this file. So this says that there are 959 files, and there's a characters, lines, words and characters. So if you only want the number of lines, we can give an additional argument L, and it will say there are 951 lines. So Maiken, we have 2 commands. One is to print the lines which has the word blue in it, and we know another command which can count how many lines in a file. So Maiken, how can we count how many lines that has the word blue in it? How can you do that?
Yeah, so that's where it will be useful to use pipes, because you can first write the grep command. That will print some out. If you just press enter now, that will print the output and you'll get lots of stuff. But if you don't want to print this output, but use that as input to the next, like the word count, you can use a pipe. That's the symbol for pipe, and then the word count and -L. Then you'll find out how many occurrences, how many lines we got. Yes, 136.
Yes. So that is the basic concept of the pipe here. So you can combine multiple. It's like words in a language. You can create pipelines, meaningful sentences, like one after another.
Yeah, it can be many after each other here.
Yes. And you see, Maiken, as you showed me, this WC here, earlier when we said WC, we had a argument here, right? But here there's nothing. So which means that the output of this command had been fed into the WC command. So why don't you try that? So let's have a type along. Type with me and see, go to this folder and see whether you can get the same output as me.
Yeah, so you'll basically just see the output of the last command.
So let's say, yeah, so I'll give let small pause to check that out. Let's see the HMD. Yes. Let's try something a little more challenging, maybe, Maiken. So in this file, we see that grep, the word line is there in this repetitive text file. So if I press enter, it will print all the lines. So I want to, so this combination of, so as we discussed, we can combine any number of commands, one after another, but the order of these things matter sometimes. Sometimes it doesn't, sometimes it's matter. So the reason I'm telling you is, if I want to get the unique number of lines, how many are there? So if I use the command unique, it will print these 3 lines. But Maiken, do you see an issue in this, the way I issued the command? Did I get the unique lines?
Yeah, I can't think right now, actually.
Yeah. So I have this another line, and then I have this yet another line and another line. So I'm going to include another command which says sort in between, and I get 2 lines. The reason is the unique will only find or consolidate unique lines, consecutive unique lines, one after another. So if you want to issue a unique command to get the result that you want, you need to sort the file first. So yes, you could combine any number of lines, any number of commands to create, some sort of meaningful grammar or like pipelines. But you have to make sure that the context of it. So you can't just combine these things. You should sort of have some sort of idea what's the output is for something.
Yeah. So
does that make sense?
Absolutely. And of course, it's not obvious. You would think that just using unique, you should be able to find each unique line, but here you see you find both another line and then another line. But so use the band page and you will understand, okay, it can only find the unique in consecutive lines. So that's
consecutive lines.
Yeah.
So how could I count how many unique lines are there, Maiken? What would the next command?
Well, then you should pipe that into the word count and -L for counting occurrences of lines. Yeah.
So then that is the main the concept behind this pipe. So after the lessons, I recommend that you go through this exercise and have a feel of it. Because we are not going to break for an exercise today, but we leave the last 10 minutes to discuss the questions that arise. But before that, you showed something very, you shared some wisdom with these man pages, Maiken. Shall we together try to find out whether during this 3 minutes, whether we can find out how to count how many of those unique lines are there. So here we see that there are 2 unique lines. But if I want to count, like let's say let's reduce a little bit, not unique, but how can I count how many of the another lines and how many of the yet another lines, to get more out of this command. I will ask the man page of unique. Then I will go prefix line by number of occurrences. So I see as the first option, if you see a C, if you include a C argument, it will not only find the unique content, it will also count them. Shall we try that, Maiken? Let's see what happens. -C. So it has found out 14 another lines are there and 2 of these. So not only consolidated, so you could find out more things with this man pages and get more details. Apart from that, anything else you want to mention, Maiken?
No, just that this is really powerful. I mean, you can create very complex commands using this, and it's very useful once you get used to it.
Yes. So in your field, you could think of, let's say, in bioinformatics, for example, there are files called FASTQ files. You need to count certain lines, find the redundant lines, find the unique lines. You could imagine an example from your field and maybe some files you actually see, and test these commands. As the last thing on the last minute, Maiken, how can I save this to a file? This output?
Yeah, I was just going to say that, there's a couple, at least 2 ways. One is to redirect this into a file, which is there's an example in the page, I believe, with the redirect sign there to out some file. But you can also store it in a variable.
Okay.
But we haven't shown that, but that can also be very useful.
So now it's a file. So how do I save this as a?
Shall we show that also? Yeah. Do that.
So in the as the first command that we learned that this dollar has a special meaning, which means it's a variable. So it printed here the output. So what I did was I used a bracket to encapsulate the output of what happened and print it. So instead of that, you could do unique lines equals this, and then you can echo dollar unique this will be, it will print.
Yeah, and this dollar you need in order to say that, put it into a variable.
Yes, so without a variable, it will not print. It will just print the word and not the line. So Dania, I would say that we could stop the recording and maybe open mic. Anybody can ask questions and we can open the HackMD.